Hi friends, myself Jivanand. Today we'll be just giving you some detail about the springs supports which will be used in the pipe systems for in industrial uses. So let's see what role of the spring is there in support as a special support for the pipe systems. First will be the contents. The content has got what is spring supports, why and when spring support is used, types of springs, selections of springs, working principles of springs, and then the advantage and disadvantages of spring. What is spring supports? Spring support is a special and a flexible support which provides support to pipe throughout the life cycle of pipe systems in a plant while allowing the thermal expansions or contractions movement in pipe. So here the pipe support will remain always active during the operating systems in pipe, and even though that's the expansion or contraction, this pipe will remain will provide the support to that pipe systems. Apart from that, we will go further to read how the role of the spring is there in pipe systems. Here is the left side the hanger two type of these are called the hanger pipes hanger spring supports, and the other is called the can type spring support. We'll see in more detail about this type of springs. Why and when spring is used? When a rigid supports are provided to a pipe, it lifts up or contracts during thermal expansions or contractions respectively. Then the pipe get lifted up and support remain inactive, or during contraction huge load is transmitted to the supports, unlike in normal sustained case. In order to prevent this lifting off or contractions in support, spring is used. So the spring will come into picture only when there is a lift up of support or excessive load is being transmitted to the rigid support due to contractions. Now, spring, due to its low stiffness, flexible in nature, takes those load during the thermal lift up, thus balancing the pipe systems and safeguard the connected equipment nozzles and prevent overstress in pipes. So it balances the systems by taking those loads, and as well as it safeguard the nozzles, equipment nozzles, and prevent overstress in the pipe. So it plays the roles of taking the load as well as supporting the, that is preventing the nozzle loads getting filled, or no excessive load will be transmitted to the nozzles, and behind the sustained limit, and also the stress will be within the limit of the code compliance. Here we can see the support is getting lifted up here, and when we provide the spring it will remain active throughout its operation cycles. Now, types of springs. There are majorly two types of spring used in the industrial. One is the variable spring, and the second is the constant springs. So these are the major two types of spring generally we are providing in the pipe systems. Selections of spring. Following criteria to be considered while selecting a spring support. Selection done based on the vertical thermal movement. If the thermal movement cross more than 25 mm, constant spring hanger has to be selected, or else we can go with the variable spring. Arrangement of spring support. Spring supports support installed below the pipe is called can type spring, and the support which are arranged above the pipe are called as hangers, spring hangers. Based on the size and stiffness. Size and stiffness get varied based on the thermal travel and pipe operating load. So based on this thermal travel and pipe operating load, the size will vary. So this we'll see in the coming slides how thermal travel and operating load plays in role in getting out this size and stiffness. Space clearance. Proper space clearance for spring installations to be kept should not hinder operations, plant operations, as well as maintenance of safety access. So it shouldn't come as the obstacles for this operations, for this movement of the people over there. Selections of springs. Now let's see, this is the spring data sheet been prepared generally for the vendor for to order them for the spring. So here the circle one is the one which has got all the technical data. So the left one shows the dimensions. The spring data has got the hot load, which we have to provide it, test loads which will be the hydro pneumatic load, vertical travel will be the thermal displacement, maximum displacement will be in the upset conditions, and turn buckle which will be provided for the hanger type spring, maximum allowable variation which we can consider, which will come as per our calculations. Working range will be the double of the displacement, the max displacement. Cold load and hot load spring rate will be provided by the vendor, which we need to calculate in our calculations, which they will provide generally along with the drawings. So selections of spring. So here we will see those arrangement of the spring. For variable spring on the top is shown, constant below. So if you just see the A, B, C, D, E till the hanger type has been shown for the variable, and the F1 is the can type springs which been shown here with the dimensions. So this dimension we are putting up in the spring data sheet for the vendor. So similar in the constant spring hanger also we can see the similar arrangement. So the look will be different, but the type of hanger or can type will be the same. So let's in the next what we have been there. So selections of variable spring. Variable springs are based on the load variations. Variations will be cold load minus hot load and hot load. That means the cold load is the preset load which we will provide it in the spring hanger, and hot load is the actual load which will remain active during the plant operation, which we call as balance load. So this will give rise to displacement and spring stiffness. So if you got the spring displacement, that is the thermal displacement, and as well as the spring stiffness value also, or you can calculate the spring stiffness from this parameter which has been provided. Now let's go calculate spring stiffness. If so, spring stiffness, as you can see, it's load variation to hot load upon displacement. So vendor generally calculate on this basis, and this spring stiffness can be selected from the vendor catalog. So once we get this spring stiffness, this we can check in the catalog also. Sometimes the value can be not exact of what vendor has been provided, but if it's very close to the nearby value, we can select those stiffness also, and we can use those as a back calculation in our calculations. Hot load can be selected by providing rest to rigid support on each support locations in normal installation temperature, which creates a balanced system. So when we provide a rigid support, we get a balanced systems during the normal operations. So those load we have to put it in as a hot load during the operation condition. So these calculated loads are used in our software as a operating load which balance the pipe system. Load variations can be considered max as 25% for variable, and sometimes we limit it to 6% if this spring is if the spring is installed near to the sensitive equipment. Selections of variable springs. So here this is the variable springs catalog provided by the vendor. So here you can see over here, these are the loads which has been put up here. The bottom one here we can see the spring stiffness. If we get the spring stiffness, for example, if I get a spring stiffness of 10, near to the 10 value or 10 exact, then I will check the displacement also, what displacement is providing, that is over here. If you see, these are in the inches value. So if my displacement, if it comes in this range, then I can go with this stiffness. Or if my displacement is lesser than this, so I will go try to move it to the nearby stiffness, that is to this one. So at the same time I need to check the load also. My load should be within this range. So the load, cold load as well as hot load, both should be within this column. And cold load should always be tried, we should try to provide it at the center during the selections of the spring. And sorry, it should be hot load, and cold load will be nearby that. So at the same time we have to see the variation, that is the working range displacement also. So based on this, we can finally select the size of the spring which we has been numbered over here. So this spring has got that, these are the name given to it, and these are the figure of particular this to this figure, this type of this size spring has to be selected. So this is how we normally select based on the catalog. So similarly, now we will just see over here the selections of constant spring. Constant springs are selected when the load variations of variable spring exceeds its acceptable value, or when the vertical pipe displacement exceeds the range of variable spring. Generally, when the variation cross more than 25% or the displacement exceeds 50 mm, constant hanger spring is selected. So constant hanger spring comes only when there is exceeding displacement of variations. Selections of constant springs. So here the catalog of constant spring is being shown. So here we can see the here the size has been provided on the left side column, and this is the travel displacement in inches, and this is the load carrying one, which where we can provide the load over here. So this whatever the load we got and the display based on the displacement, so we can select the size. So let's now see the working principles of variable spring. In this, the spring imparts partial loads or other on other nearby supports or connected equipment. The spring remains active throughout operations and load carrying capacity varies based on the movement of pipe in vertical up and down direction, hence the name variable spring is given. So this imparts some partial load to the nearby support too. Also, you don't take the 100% full loads on it like the constant spring supports. So here it will but the support will remain throughout active and will take the load carrying capacity based on the stiffness. A variation of 25% is set for this type of springs of any sizes. Variation is cold load, that's the formula which we have seen earlier also. Cold load is set in spring during installations and it is locked in this position. So this called the installation set of load is called preset setting. And during operation, set pin is opened, and in operation state the indicator is brought gradually towards a hot load point, that is during the operations it will come down normally to that particular point. So here we can see that point here the indicator will be there, this will be the stopper. So here this the spring, there will be some preset will pin, the pin will be inserted here during the time of installation, and we will remove when the spring is completely installed. So this is the can type spring. Here we can see the same indicator. So the red line will show the preset load. So when we'll go, they will remove this red line. That is the stopper where it has been set up, and the plant once is in operation, it will come the load. The indicator will come close to the hot load pointers. Working principles of constant hanger. So here as the constant hanger will generally take the constant load, there won't be any variations. You once you set the load for 25,000 kg, then it will take a 25,000 kg load itself. We don't transmit any other load to any part, to any systems, to any nearby support or nozzles. So here the working principle is that the stiffness, that is that here that the moment W cross L is controlled by the spring stiffness and distances. So the moment here is controlled by the stiffness, that is the F, as well as the S, the distance which between the pointer and the fixed point, that is the fulcrum. If the distance L increases, the moment will increase, which lead further to the spring to carry lesser load. So this distance will govern the factor of carrying the load, because the moment it increases, the load carrying capacity will get reduced. So this is how the working principle of constant spring take place. Now let's see the advantages of springs. Reductions of stresses. It takes the loads of those support which remain inactive because pipe lift up. Thus it reduces the stresses. Equipment nozzle load protections. By taking a balanced operating load, it safeguards the nozzle loads from overstress. No overload on adjacent supports. The lift up support which carries zero load is now balanced by the spring which takes proper operating load, and is no overstrain or loads on adjacent support during operating conditions. So this is how it takes place. This is the advantage of the springs. Now let's see the disadvantage. Maintenance need. Proper maintenance is needed to in order to prevent any dust or foreign material to deposit in between the coil of the spring. So when it's open, there is a chance here you can see it got rusted, and there can be dust particle to get inserted or foreign material to get inserted inside between the coils. Setting of cold load. During shutdown activity, spring needs to be set in cold settings and locked with pin. It takes considerable time and effort to bring setting back to cold state, load state. So once you shutdown activity is started, so at that time the spring has to be brought back to its normal position, that is in cold setting. So it's really tough to bring it back to the cold setting. You have to press the springs. The stiffness of the coil is too, if it's too hard, external equipment is required and a lot of time is spent in this kind of things. Cost of spring is more than normal rigid supports or simple hanger, especially constant spring hanger is more costly than variable spring hanger. So cost also plays a role here when we go for the selections of spring. So that's all, friends. Thank you. Hope you get a lot of things from here. If anything is there, you can post me, and you can put me in the groups in that YouTube's. Okay, thank you. See you. Bye bye.